Hello my dear students, welcome back to my channel. Today we are going to start our new chapter, that is Algebraic Expressions and Identities. In this video we are going to focus on the basics of algebraic expressions that will enable us to understand the difference between like and unlike terms, and it will clear our doubts whether the given terms can be simplified or not. So please watch this video attentively till the end. Now let's begin. Okay, before going into the detail, I would like to answer a very common question which come into all of our mind, that why do we need to learn these algebraic expressions? So my dear children, the basic use is the rules and formulae in maths are written in a concise and general form using algebraic expressions. In simple words, if I'll say, it is helpful in making the formulae in maths. Also, they are useful in formulating puzzles and problems. I have taken one example of an identity over here. So this is, again, we are able to use these identities only because some mathematician framed these identities by the help of algebraic expressions, or by using algebra, we can say. You know this formula to find the area of a circle when radius r is given. Likewise, we have the formula to find the circumference of a circle of radius r. We have some more identities. So the formulae or the identities we were able to frame just because of the algebra. Now let us move on to our chapter. So whenever we think of some algebraic expression, these kind of examples might come into your mind. So these are the examples of algebraic expressions. So if I'll ask you to define algebraic expression, just by seeing these examples, you can also try to define them. Like the combination of constants and variables. And also the operations are there. Addition, subtraction, multiplication and division. We know very well what a variable is, right? We use letters X, Y, Z to denote variables. A variable can take various values and its value is not fixed. That's why it is named as variables. On the other hand, constant has a fixed value. And you can see the examples over here only. X, Y, Z, the 7 is the constant, X, Y, Z are the variables, and the operations we have minus, plus, in between we are having multiply, here y upon 2 we are having division. So these are the examples of algebraic expression, and this is how we define algebraic expressions. Let me give you one more example. 4x plus 5. So when we are seeing this algebraic expression, we see that x is the variable. Since 5 is alone, it is not having any variable with it, so it is the constant. And the number which is written in multiplication with this x, it is the coefficient of x. And whenever it is asked to write the coefficient, we always see the sign also of the coefficient. So here, since plus is the sign with 4, that is why we are just writing simple 4. Otherwise, if I would have taken minus 4x plus 5, the minus 4 would be the coefficient over there, right? And 5 is the constant. This I have already told. Now, one more example. Here we can see how many variables. 3 variables are there. X, Y, Z are the variables, right? And coefficient of x. What is the coefficient of x here? If nothing is there, it means 1 is there. Don't write 0. Don't take 0, because if you will say 0, so they are in product with each other. They are in multiplication with each other. 0 into x will give you 0. So then this term only will get disappear. So here the coefficient of x is 1, coefficient of y is 3, and of z is minus 6. Now let us go into the detail of terms. When we are saying terms, we took the example 4x plus 5. In that, 4x is a term and 5 is another term. How do we know that? So let me take one more example. Here I'm saying that there are 3 terms, 2x plus 3y minus 5. How do I know that? So this I came to know because of plus and minus sign, plus and minus sign, because the terms get separated by these plus and minus signs, right? Now, if I'll ask you, yes, one more thing, that when we are writing the expression, if I'll try to write it in the standard form, I can write this as plus bracket minus 5. Now, if I'll tell you what is a term, term is the product of factors. What does it mean now? If I'll see 2x, how do we get this 2x? We get this 2x by multiplying 2 with x. So 2 into x is giving us 2x. And this is how we are defining the term. A term is the product of factors. 2 is the factor of 2x. X is also the factor of 2x. Because when we are multiplying these two factors, we are getting the term. Right? Similar way, if I want to write this 3y is written as 3 into y. Minus 5 can be written as minus 1 into 5. Right? So term is the product of factors. Now, why I'm telling you all these things? Because this is going to help us in determining whether the given terms are like terms or not. Let us take one more example. In this example, there are 4 terms. I hope you are able to figure out yourself that how I got this answer, 4 terms. Now, if I try to write these terms in terms of its factors, minus 2y cube, we can write as minus 1 into 2 into y into y into y, because y cube is there. 5x square y is equals to 5 into x into x into y. 21z is equals to 3 into 7 into z. As I told you, we need to write these terms in this way. In the beginning, we are going to write, because this is going to help us to identify whether the terms are like terms or not. That we will see in the subsequent slides. So coefficient of y cube, if I'll ask you here that what is the coefficient of y cube, I hope you can easily answer that. Coefficient of y similarly. Okay, when I'm asking you coefficient of y, so here we don't have as such a simple y. So if I'll ask you here y coefficient, so I'm having this term. So other than leaving that y, whatever is remaining, that will be the coefficient of y, right? Numerical coefficient of x square y. Now numerical coefficient specifically means only 5. Now let's see the answer. So coefficient of y cube is minus 2. Coefficient of y is 5x square. Numerical coefficient of x square y is 5. Correct then? Now I hope you can easily identify the coefficient of terms other than constant in this expression. So here if I'll ask you what is the coefficient of y square x square, I hope your answer is 1, because nothing is there. So coefficient is 1. Coefficient of x square y is minus 10. Please don't forget the sign. Coefficient of xy, 5. And minus 20, of course, this is a constant term, so there is no coefficient. Now, when an expression is containing only one term, that is known as monomial. As we can see here in the examples that we have taken only one term, that is 2x, 61 PQR, though it is having 3 variables, but it is a single term only. Minus 8, though it is a constant, still, since it is a single term, it will be considered as monomial. And you can take several examples by yourself. Now, what are binomials? Again, the expressions that contains only 2 terms, those are known as binomials. And we can see the examples here. Z plus 2, 2 terms separated by plus here. 7 minus 2yz, 2 terms separated by minus over here. So, since the expression contain only 2 terms, so it is a binomial. Now, similarly, if we are having 3 terms, that is known as trinomial. We have quadrinomial also, that I have not taken over here. In the similar way, now if we'll generalize this, in general, an expression containing one or more terms with non-zero coefficients. Okay, coefficient should not be 0. And with variables having non-negative integers as exponents. Now, what do you mean by this? Variables having non-negative integers as exponents, that is known as polynomial. So, let me just explain this with the help of an example. Like I have taken this example x square minus 3xy. So here, if you can see, there are two terms having variables x and y, and here the coefficient of the term here of x square is 1 and here it is minus 3. So these are non-zero coefficients. Okay, the meaning of non-zero coefficient is like here the coefficients are non-zero. Fine, one condition satisfied. Now one more thing they have given over here, and that is very important to identify whether the given expression is a polynomial or not. That is, the variables should have non-negative integers as exponents. Exponents means power of the variable. Now the power of the variable should be a positive number, positive integer. Non-negative integers means positive integers or zero. Or in simple words, if I'll say whole numbers. Whole numbers can be the exponents of these variables. Fine. Then only we will say that a given expression is a polynomial. This is very important. To identify whether the given expression is a polynomial or not, you have to keep it in mind that the coefficient should not be zero and the exponent on the variable, the power of the variable should be a whole number. And you know, zero can also be there, right? Because zero is also a whole number. Fine. So this is about polynomial. In detail, you are going to learn about polynomials in class 9. So not to worry. A whole chapter, the whole chapter only is based on this polynomial over there. Fine. Okay. Now, important points to be noted for an expression to be a polynomial. I just have explained you over there already in the previous slide only. So non-zero coefficient should be there, non-negative integers or whole numbers as exponents of variables should be there. When I'm saying the exponent should be a whole number, that means exponent cannot be negative. So here if I'll say, I have given the example 1 upon x. So in the first instance, you will feel that it is a polynomial since a variable is there. So we can say that it is a polynomial, but if we'll try to write this 1 upon x, we can write this as x raised to the power minus 1. So here, then the power of the variable will become minus. So this is not a polynomial. This also, since x square is in denominator, so if we'll try to write it in the numerator, it will become x minus 2. So that is again not the case of polynomials. It is not satisfying the definition of polynomial. So we will say that these are not polynomials. Fine. And the exponent cannot be in fraction also. Yes, one more thing. This exponent, the power on the variable cannot be in fraction also. Fine. So if you're getting the terms like this or 2 root x or 3 root y plus y square, this is also not a polynomial. So these 3 points we need to keep in mind when we are checking for whether the given expression is a polynomial or not. Fine. Right then. Okay, this I already told you, whereas the coefficient can be in fraction or an irrational number also. Okay, these rules does not apply for the coefficient. Only thing for the coefficient is that it should not be 0. So if we'll see here, root 3x square plus 6 upon 2, you might get confused that, okay, root 3 is there. So root 3 is the coefficient of the variable. So it can be a polynomial. We'll have to check for the other conditions also, like the variable, the exponent on the variable should be positive integer only. So yes, that is there. So fine, this is a polynomial. Again, minus 5y cube, as we told that, okay, fine, minus should not be there. So keep it in mind that minus 5 is the coefficient of y cube. Fine. So this is also a polynomial. So the confusion should not be there. What we have learned that the coefficient can be negative, the coefficient can be in fraction, but the power of the variable cannot be negative, cannot be in fraction. Right? So I hope you have understood well. Now let's learn the addition and subtraction of algebraic expressions. So which all points we need to keep in mind while adding or subtracting the algebraic expression? Before that, uh, can we simplify this 2x plus 3y? If no, why not? Do you have any answer? Yes, the answer is like and unlike terms. We need to know the concept of like and unlike terms. Then only we can answer whether these two terms can be simplified further or not, right? So let's see. Let us just take the examples of the burgers. Yes, if we have three burgers and we have bought five more burgers for our friends or when we are going for some outing, so how many burgers we have bought in total? Can we add them? Right? We can add them. Yes, we can tell that we have bought eight burgers for us. Fine. Now, if we have bought only two burgers and five French fries, can we just add like burgers? In total, can we say that, okay, eight or five plus two French fries burgers we took? No, we cannot add them as such as we added the burgers, right? We will just say, yes, two burgers and five French fries. In that way only we can say, isn't it? One more example, let us take that if I'm having 10 French fries and six French fries I had to give to somebody else, then how many French fries I'm left with? The answer is easy, four French fries. Fine. So in case of minus also we have seen that when we are doing subtraction, we need to have the same things, then only we are subtracting. Okay, one more case we have. I bought two cold drinks, five French fries, two burgers. So can I just tell in total how many things I have bought? Yeah, easily we can tell. Two burgers, five French fries, and two cold drinks. Is there any other way to tell this? No. Fine. Then again, 10 French fries minus 4 French fries plus 1 burger. What will be the answer? 10 minus 4, 6 French fries plus 1 burger. Fine. So why I am discussing about French fries and burgers and cold drinks here? Am I going to give you a treat? No, I'm not going to give you any treat right now. And we should not go for the fast foods also. That is not healthy for us. Okay. So why I'm telling about or why I'm discussing about all these French fries and burgers, we can see here when the things were same, then only we added them or then only we subtracted them. When the things were different, we just kept them in that way only. We could not add them, we could not simplify them, isn't it? And when we had the mixture of both, like same things also, different thing also, so we just took the same things, we subtracted the same things and kept the different things as it is, right? In the similar way, if I'll tell you that burger is nothing but X, anything, isn't it? Now I'm generalizing it. And again, this is the burger, so I'm taking this as X. So 3x plus 5x, how much will you get? 8x, right? Now, if I tell you that, okay, 2x, and let us just take that the French fries is y, 2x plus 5y, can I add it? Can I add them? No, I'll just tell, okay, two burgers and five French fries. I cannot mix them, no? Isn't it? Similarly, here. So I hope you have understood, you have got me right that when the terms are same, then only we can add them or subtract them, right? It means those same terms are nothing but the like terms and the different terms are nothing but the unlike terms. So now I hope you can answer confidently when I'm asking you that what will be the answer of 2x plus 3y. You will say 2x plus 3y only because it is already added. We cannot simplify it further. But what do we do in exam? What do we do in exam or in our notebook? That we just try to add them. We give the answer like 5xy, isn't it? Many of you, most of you do this mistake. So please keep this example of burger and French fries in your mind. You can just take this example to understand the why we cannot combine some terms and why we are combining some terms. Okay, so I hope this concept is clear. Let us move ahead. As these are unlike terms, we cannot simplify them further. Okay, now we have got the reason also. Now please observe the following expressions and identify the like terms. I hope you can easily identify the like terms. If I'm taking minus 2x, I have to see whether there is any other term having the same variable. Yes, there is also one same variable, x is there, 4xy, but one more extra variable is there. So I cannot consider this as the like term to this. Okay, so minus 2x, minus 13x. Yes, that's all. 4xy, 3xy, these are the like terms. Fine. And similarly, you can check out that 9x square minus 2x square, these are the like terms, and 18xyz is the alone. Fine. I hope you have understood the concept now. Now you can think of more terms which are like given example. You can just take some more example. As I've taken minus 2x, minus 13x, you can give me, ma'am, 7x, 5x, 100x. In the same way, you can think of more terms like this, right? Okay. Also, now if we want to add or subtract them, now we can do. Okay, if I want to add this, I can easily write, okay, minus 2x minus 13x minus minus, same sign, add and put the same sign. We know the rule now. So minus 15x will be the answer. So we can add or subtract the terms only when we know that the terms are like terms, right? So what we have learned, to identify like terms, what we need to look for? We need to look for the same variables. Fine. Powers of these variables should be same, right? Numerical coefficients need not be the same. Numerical coefficients can be different. And the order in which the variables are multiplied need not be the same. Now, what do you mean by this? I'll just explain with the help of example. Let us just keep one more note with us. Like while adding or subtracting algebraic expressions, first look for like terms and add or subtract them, and then handle the unlike terms. This we have already understood. So now let us see. When we have to identify like terms in the following, this is the question. So I have written the terms like this, and I have written the factors. Minus xy square, the factors are minus 1 into x into y and y. Fine. I have not written multiply. It's okay. I have just written the factors. And in the similar way, when I'm writing the factors, now I know which all variables the term is having. Fine. And also, as we studied, that the order of the variable, whether that in which order they are multiplied, that doesn't matter. So when I'm writing minus 4 yx square, the factors are minus 4 y into x, yxx. So we just need to see which other term is having the same variables, x, x, y. So 30x square y and minus 4yx square, they are the like terms. That is why I have given them the same color, blue color. Similarly, minus xy square, 3xy square, like terms. Why? Having the same factors. Okay, so when you are looking for the like terms, what we need to see, first of all, the variables should be same and the powers of the variable should be same. As here we are having 2y's, y into y. This also we are having y into y. Similarly, yx square, 1y, 2x, y into x, and this is also having 2x and 1y. Okay, so the powers of the variable is same. Similarly, 5x square, 11x square, 7x square, these are the like terms. Y, single y, 5y, 1y. We are not talking about coefficients. We are just seeing the variables. Then 2xy, 2 into y, and minus 11 into yx. See, the order is different, but again, they are the like terms only since the variables are same only and the powers on the variable is same. Fine. So this is how we can identify the like terms and unlike terms. And obviously, when we have identified these are the like terms, these among themselves they are unlike, because xy square, we cannot take this as equal to yx square, since here the power of the x is 1. Here in this term the power of the x is 2. Here it is 2. the power of y is 2, here it is 1. So they are unlike terms. So I hope this concept of like and unlike terms is clear to you. Now you can easily do the exercise, the first exercise in your book. And I'll give you some more questions based on how to do the addition and subtraction of algebraic expressions in the next video.